Hello everyone, welcome back to my YouTube channel. Today I'm here to discuss about the topic F distribution. So let's start with the introduction to F distribution. The F distribution is a probability distribution that arises in the context of statistical hypothesis testing. It is used to test the equality of variance from two or more populations. The F distribution is continuously probability distribution that takes only positive values. Characteristics of F distribution. The shape of the F distribution depends on the degree of freedom associated with the numerator and denominator. The F distribution is always positively snail. The mean of the F distribution is not defined when the denominator degree of freedom are less than 2. So let's see the notation for F distribution. The F distribution is denoted as f of df1, df2, where df1 represents the degree of freedom of the numerator and df2 represents the degree of freedom of the denominator. The degree of freedom determines the shape and scale of the distribution. The numerator degree of freedom must be positive integer, while the denominator degree of freedom must be a positive real number. So let's see the relationship with t distribution. The square of a t distributed random variable with degree of freedom equals to df is an f distributed random variable with numerator degree of freedom equal to 1 and denominator degree of freedom equal to df. This relationship is used in hypothesis testing and confidence interval estimation. The F distribution can be used to test whether the variance of two populations are equal using the F test. F distribution and ANOVA. The F distribution is widely used in analysis of variance, ANOVA, to test for difference between group means. ANOVA decomposes the total variability of a data set into within group variability and between group variability. The F distribution is used to compare the ratio between group variability to within group variability. So calculations of F statistic. To calculate the F statistic, the sum of squares between the group is divided by the sum of square within the group. The F statistic is then compared to critical values from the F distribution to determine statistical significance. The F statistic follows an F distribution under the null hypothesis of no difference between group means. Critical values of F distribution. Critical values of F distribution are used to determine statistical significance in hypothesis testing. Critical values depend on the significance level and the degree of freedom of the numerator and denominator. Tables and statistical software can be used to find the critical values of a given F distribution. So let's see a few applications in detail. Analysis of variance. In ANOVA, the F-test is used to compare the variance of multiple groups. The F-statistic is the ratio of the variance between groups to the variance within the groups. If the ratio is significantly different from 1, it suggests that at least one group mean is different. So regression analysis. In regression analysis, the F-test is employed to assess the overall significance of model. It compares the variance explained by the regression model to the unexplained variance. A significant F statistic indicates that the model's coefficients are jointly different from 0. Quality control. The F distribution is used in quality control to compare the variance, such as assertion whether the variance of product dimension from different product runs are significantly different. Experimental design. Experimental designs, particularly those involving comparisons of multiple treatments of factors, often utilize the F distribution to test the significance of difference between groups. So let's see about the interpretation. In hypothesis testing using the F distribution, analysts compare the calculated F statistics to critical values from statistical tables. If the calculated F statistic is larger than the critical value, the null hypothesis, that is often starting equal variance or no group differences, is rejected. It's important to consider the context of specific application when interpretation F statistics. Large F values may indicate significant differences, but their practical significance should also be evaluated. Relationship with chi-square distribution. The F distribution is related to the chi-square distribution. When the numerator degree of freedom of an F distribution is equal to 1, it is equivalent to the chi-square distribution with df2 degree of freedom. This relationship is useful in certain statistical tests. So let's see the applications of F distribution. The F distribution is used in various statistical techniques, including regression analysis, analysis of variance, and quality control. It is used to compare variance, test for differences between group means, and asset model fit. The F distribution provides a basis of making inference and drawing conclusion in many areas of research and data analysis. Advantages of F distribution. The F distribution allows for a comparison of variance across multiple populations. It provides a framework for hypothesis testing and confidence interval estimation. The F distribution is widely used in various fields, including statistics, economics, engineering, and social science. So let's see the limitations of F distribution. The F distribution assumes that the population being compared are normally distributed. It is sensitive to violations of assumption of normality. The F distribution is also sensitive to violations of the assumption of equal variance. So let's see a few examples of F distribution. An example of using the F distribution in comparing the effectiveness of two different technique methods on student performance. Another example is testing whether the variance of two different manufacturing processes are equal. The F distribution is also used in analyzing clinical trials to compare the effects of different treatments. Assumptions of F distribution. The key assumptions of F distribution are independence of observation, normality of population being compared, and equality of variance. Violations of these assumptions can lead to misleading results. It is important to assess the assumptions before applying the F distribution in statistical analysis. So let's come to the conclusion. The F distribution is a probability distribution used in hypothesis testing and confidence interval estimation. It compares the variance of two or more populations and is common used in ANOVA and regression analysis. Understanding the F distribution is essential for making valid statistical inferences and drawing accurate conclusions. So thank you for watching my video. Like and share the video.